In section 3.3, we're going to look at another law called the cosine law. Well, why do we need this law? Take a look at this triangle. If I set up everything I know in the sine law, I do not have enough information to solve for my unknown side q. So the sine law can't always help you determine the unknown angle measures or side lengths. Another relationship between angles and sides is called the cosine law, and it comes from the Pythagorean theorem. The Pythagorean theorem requires a 90-degree angle. So, to prove this, the first thing I did was I drew my height of my triangle so that I would have a couple 90-degree angles to work with. So I drew this height, h, which separated side A into two line segments, y and x. So, my first step is to write two different expressions for h squared, using the Pythagorean theorem. So, x squared plus h squared is equal to c squared. If I subtract x squared from both sides, I get that h squared is equal to c squared minus x squared. But then I can also use the other triangle. And I can say, well, h squared plus y squared is equal to b squared. I can subtract y from both sides to get that h squared is equal to b squared minus y squared. Then by the transitive property, because I have h squared is equal to this and h squared is equal to this, I can set them equal to each other. So I have b squared minus y squared is equal to c squared minus x squared. Solving for c squared, we get that c squared is equal to x squared plus b squared minus y squared. But then, if you look back up here, because a is really equal to this segment plus this segment, or x plus y, then I can say that x is equal to a minus y. So we can substitute a minus y in for x. So then c squared is equal to a minus y squared plus b squared minus y squared. So then c squared is equal to, once we distribute, or FOIL, a squared minus 2ay plus y squared plus b squared minus y squared. And then we can simplify because we have y squareds that'll cancel out. And we get a squared plus b squared minus 2ay is equal to c squared. But then, cos of angle C is equal to y over b. So cos of our angle C is equal to adjacent over hypotenuse, or y over b. Okay, yep, that's true. So then, if we solve for y by multiplying by b on both sides, we're going to get y is equal to b cos c, and then we can substitute that value in for the y in our equation. So c squared is equal to a squared plus b squared minus 2ab cos c. This is one form of what's known as the cosine law. Here are the other forms of the cosine law. So as you can see, it does apply to all the other sides. The other two forms can be proven the same way, but with different heights of the triangle. So back to the original question then. So using one of these, I'm going to use the first one. Using this, I can solve by plugging in the values I know. So q squared is equal to 3.1 squared plus 3.2 squared minus 2 times 3.1 times 3.2 cos 66 degrees. I can plug this into my calculator, and I get that q squared is equal to 11.780345. But then I have to take the square root of both sides. So I get that q is equal to about 3.4. So this, in summary, can be found on page 136 of your textbook. It's a really good idea to take a look at it. The cosine law can be used to determine an unknown side length or angle measure in an acute triangle. And then it gives you the three forms of the cosine law. You need to know that you can use the cosine law to solve a problem that can be modeled by an acute triangle when you know two sides and the contained angle. So you have side, angle, side. Or you know all three sides, and then you can solve for an angle. The contained angle is the angle between the two known sides. When using the cosine law to determine an angle, you can substitute the known values first, then solve for the unknown angle, or you can rearrange the formula to solve for the cosine of the unknown angle, then substitute and evaluate. It's totally up to you. I like doing it the first way, but you can do it the first or the second way. It doesn't matter to me.